So how might we append two lists? So for example, we might want to append the list 1, 2. We've seen the append operator, of course. So that gives us the list containing all those elements. But how might we write the append operator ourselves? Well, we're going to need a function append and what we'd like is for that to do exactly the same as the built-in append function and give us 1, 2, 3, 4, 5. Well, what would the type of this append function be? Well, in our example here, these are both integer lists, but we know that the append function is actually going to be general. It's going to be able to append any kind of lists, so long as the kind of lists are the same as one another. So we'll call these alpha list. So what would the type of the whole append function be? Well, we know that it's going to take two things and return a third, so we can put some arrows in. And the first thing is going to be of type alpha list, the second of type alpha list, and what will come out at the end? Well, another list, which is the list of the two input lists appended to one another, and so that has to have the same type alpha list too. So that will be the type of our function. How might we construct such a function? Well, in this case, it's not entirely clear what the appropriate base case is. It looks like we're going to have to process one of the lists, at least, or possibly both, by taking them apart in the usual way, using pattern matching. Let's see what happens if we take apart the first list. So let rec append, let's call our lists A and B equals, well, what are the cases if we match on the first list? Well, the simplest, what we hope will be the base case, is that A is empty. In which case, well, what is the empty list appended to B? Well, it's just B. So what's the other possibility for A? Well, if it's not empty, it must have a head and a tail. In which case, what do we want? Well, the first element of our result list must be H. The first element of A becomes the first element of the appended list. And what else do we want? Well, we still want all the things that are in T, and we still want all the things that are in B in the correct order. So the appropriate thing to do is to append T to B. And by recursion this will work. Let's see how it might work on a simple example. If we have, let's use the example we wrote above, append 1, 2 to 3, 4, 5. Well, this whole thing is going to reduce then, we match A, it's not the empty list, so we take it apart, head and a tail. So we're going to put the head, which is 1, first, and then we're going to call again append on T. T here is the list just containing 2, and B is unaltered. Well, what happens next? Well, again, it's not the empty list, it's not the base case, so we do this again. In our example now, H is the integer 2, and T is the empty list. So effectively we're now reducing. Let's just underline the part we reduce. So we've still got this here. This is being reduced again to 2 cons. Well, now we have append the tail T, which is now in place of A, is the empty list, and we still have 3, 4, 5. Well, what happens now? Well, now we do have the base case, bingo. So we still have these parts here, 1, 2, and it says in our base case, we'll append, if A is the empty list, then we just return B. So that's 3, 4, 5, which finally reduces to our answer, 1, 2, 3, 4, 5. The question then arises, well, how long does this operation take? Well, we have to call append once for each item in the first list, because we're taking the first list apart and putting it back together again. But we don't touch the second list at all, so it doesn't matter how long the second list is. So the time taken is in fact proportional to the length of the first list. In other words, the argument A. And that's how to append 2 lists.